Domain and range. Objectives. By the end of the lesson, you should be able to find domain and range of a function given a graph, and find domain of a function given an equation. So let's talk about domain and ranges. So domain is how far your graph moves on the x-axis, how much of it covers on the x-axis, so that's my domain. And my range is how much it covers on the y-axis. So there's your range. So domain is x, range is y. There's lots of ways you could write the domain and range. So one is called set notation. So let's look at this number line here. So right, you can see x is greater than or equal to 3. So you could write interval notation, we just go x is greater than or equal to 3. You could write set notation, x such that x is greater than or equal to 3. I have to think of interval notation like this actually. 3 to infinity. Because if you look at where we start at 3 and we're going all the way to infinity. Either of these is fine. Same thing with this, you could write set notation or you could write interval notation. Again, I would think of interval notation as, oh, this is negative infinity, and this is 2, parentheses, because it's an open circle. So we're going from negative infinity to 2. But either way, this is fine. When you go from negative 2 to 1, right, so this would be open negative 2, so parentheses, and then close at 1. So bracket. This is, by the way, a colopen set, close and open. Then you have something like this, right? So less than 0, greater than 4. You could write it this way, you could write it this way. If we're doing interval notation, I could say negative infinity to 0, union, 4 to infinity. So that's how you write. If I want to write an interval notation like this, you just put a union to connect them. So all those are different ways you can write it. Now let's look at a few examples. So here we're going to find domain and range of each. To remember domain, we want to go think about left to right. That's how you want to look. So domains are x values. So my farthest x I go is negative 1. This is the furthest we go. Right? Negative was the first we go in our graph, and then if you follow the graph as it keeps on going, the farthest right is an arrow. So it's infinity. So kind of like this. And you write an arrow to infinity. So we have bracket negative 1 to infinity. Or you could just say x is greater than or equal to negative 1. That also very true. So either way you want to write it, it's totally fine. Notice it is a bracket or it greater than or equal to because it is a closed circle. Range, it's the y values. We want to go low to high. That's how we want to look at it. So if we're doing right here, my lowest is negative 3. Also a bracket or equal to sign. And then highest you go, my graph, remember, as you follow the graph, what's going on the y? On the y, it's going all the way to infinity because of the arrow. So it's from negative 3 to infinity. Or you could just say y is greater than negative 3. So again, either way, you don't have to write both, just whichever way you feel more comfortable writing it is fine. So the next one. Now domain. Farthest left is I see an arrow. Farthest right, I see an arrow. So we're going left to right. So arrow, arrow. So domain is negative infinity, positive infinity. Or you can write all real numbers. If anything works. My range, what's the lowest I see? Well, lowest is an arrow. So negative infinity. And the highest is right here, which the y value is 1. And it is a closed circle, so bracket. So my range, which is the y value, I would say negative infinity to 1 with the bracket. Oops. Bracket, there we go. Or you could say y is less than or equal to 1. So you don't have to write about whichever one you feel more comfortable writing, it's fine. The next one's a little more interesting. Alright, so my domain is my x. What happens on domain? So farthest left, arrow, negative infinity. Farthest right at the stop right here at the asymptote, the vertical asymptote, at the stop at 2. So I have negative infinity to 2. Then I start again. Now again, look at the x, not the y. It's on infinity. You start at the x. This is at 2. You go all the way to an arrow. So 2 to infinity. So union 2 to infinity. Right? Or you could say x is less than or equal to 2, or x is greater than or equal to 2. Or you could say x is not equal to 2, whatever. So that's the domain. My range is the y values. So lowest I see is right here, right? So it's a negative infinity. Again, we got to stop right here though. 1, nothing crosses 1. So 1, so negative infinity to 1, union, then we start at 1, go all the way to infinity again. 1 to infinity. So there we go. So that's how we do domain and range by reading a graph. You just kind of look at the graph, left to right, low to high. What happens if I give you an equation? Well, there's some natural domains we have to know. So natural domains. So what we want to think about is what can you not plug in? What can you not sub in? So like a square root function, right? You can't have negative numbers. So my domain naturally for that one is just going to be x has to be greater than equal to 0. Whatever is the radical x, that's your domain. So for example, if I gave you x minus 3, I want to know what the domain was. You get the thing underneath the radical, you go x minus 3 has to be greater equal to 0. So x has to be greater equal to 3. If it's a fraction, you can't divide by 0. So whatever in the denominator cannot equal 0. And if it's 1 over the square root of x, well, you can't be equal to 0 because it's a fraction, and you can't be you can't be negative, so it's actually a combination of these two. It's this one, but take away the equal to sign, and you just get that. And as right now, everything else is all real numbers. That's what this means. It means you can plug in, right? There's no issue. If it's x squared, you can plug in anything you want. So I think it's not one of these right now. It's all real numbers. Eventually we'll learn other natural domain functions, but for now it's really just a square root and fractions to worry about. Okay, let's do another example. For each following graph, the domain range. So my domain here, left to right, negative infinity to right here, I stop at 8. So negative infinity to 8. My range, my lowest I see is right here, low to high, right? Going low to high, what's the lowest I see? Right there. Negative 2. And my highest is an arrow, infinity. So negative 2 to infinity. Next one. Another parabola, we did this earlier, right? Negative infinity to positive infinity. So that's my domain, arrows on both sides. So you could write this, or a lot of times we like to write this. My range, lowest I see is negative 1, and then the highest I see is an arrow. So negative 1 to infinity. So there we go. Now in this one, we want to find the range of each function. So if you think about, the way we do it is, if you think about a quadratic, it's quadratic theory. Quadratic equation looks like this. So my range would be whatever that is to infinity. So it's wherever you start to infinity. So look at this first one here. X squared plus 2 would kind of look like this. So my range would be from 2, right, all the way to infinity. That's my range. In general, range is so much easier to do with the graph. So shortcut doing range is honestly there's no shortcuts. Just look at the graph, or leave the graph in your head for the most part. Now in this next one here, so you don't have to actually graph it if you know what the graph looks like. Oh, this is a parabola. But where do I start? At 3. It's gonna be a parabola at 3. So my range will be 3 to infinity. Again, if you actually graph, you don't have to graph perfectly, but my vertex would be negative 1/2, inside opposite, outside follow. So you start at negative 1/2 and 3. But it's inside effect. This is the next one. Now it's not 8 because that's 1. So we actually got to find the vertex on this one. So again, the easiest way to do is kind of think about graphing it. So how do you find a vertex? X equals negative b over 2a. So negative 2 over 2 times negative 1. So negative 2 over negative 2, so 1. That's the x value of my vertex. I need the y value because I'm doing the range. So you sub it in. I get negative 1 plus 2 plus 8, so 9. So my vertex is 1, 9. Now if you want to do the range from here, you could. It's either 9 to infinity, or, like it is in this case, it's upside down. It's negative infinity to 9. But again, I always think the easiest way to do range, honestly, is just graphing it. So let's just look at the graph real quick. 1 and 9, doesn't be perfect. It's a negative, so it opens down. So it's like this, which makes my range from here to here, negative 9 to infinity. Sorry, negative infinity to 9 is what I meant to say. Low to high, negative infinity to 9. And I can draw an eye for a second. So there's my range. So there we go. Next one's the domain range of each one. We're going to say the domain. The range, I would use the graph. So domain of this one here, it is a radical. So remember, if it's a radical, only thing you get anything inside the radical, so that's greater than or equal to 0. So you can't be negative. So you just add the 5 over. There's your domain. If you want, you could write that in set notation or interval notation, which would be 5 to infinity. But honestly, this is a case where like that's just easier. I just leave it like that. This one's a fraction. Right, remember the rule for fractions is it can't divide by 0. So that's your domain. So at the bottom not equal to 0. Then just solve it. So there you go. X not equal 5. Again, if you want to do interval notation, you can. You could try and draw a picture of it, right? You have a line here. You just can't be 5. So open circle by 5. Everything else you could be. So be negative infinity to 5, union 5 to infinity. But honestly, too much work. Just keep it like this. That's totally fine. X not equal 5. You can be anything you want but 5. This one here, it's a fraction and it's a radical. So let's keep that in mind, right? So the radical part of it would be this. X minus 5 shouldn't do that. Let's do all of it. X minus 5 must be greater or equal to 0. Like that's the radical part. But then it's a fraction. You can't divide by 0. So take away the slope right there. So it's just this. I have to be positive and I can't be 0. So then we just solve it. And there's my domain. And then if you wanted to look at the ranges, you would either the graph or either know these graphs kind of by heart. Like if I want to do the range on A, I know it's a square root graph. So in my head, I know it looks like this, which means my range is from 0 to infinity. So either graph with your calculator or graph it by hand. In general, the easiest way to do range is by graphing it. Next one, we're going to use technology to help us graph sketch these functions and locate turning points, hence the domain range of the function. So we're going to use a calculator. Here we go. So I want to graph to y equals. Let's type that in. Negative x to the fourth, caret for any power you want, plus 2x minus 7. Then we want to graph it. I have a normal window right now. See, it looks like it is a negative x to the fourth graph. So it is kind of like a parabola opening down. So you can see it right there. Like that's the max. Now it's x to the fourth. So it is going to be, if I look at the graph, it's going to look like this. It kind of looks like a parabola. So my domain is all row numbers, right? Negative infinity, positive infinity, or negative. So all row numbers are negative infinity, positive infinity. The range is much more interesting. Look at the range. It's from negative infinity to this point right there. So my range will be from negative infinity to the point right there I have not found yet. So how do you find it in your calculator? Well, this is a local max. So we're going to hit second calculate, and we're going to find the maximum. And all you have to do is go to where the maximum should be, like around there, and then go a little bit left of the maximum, and go a little right of the maximum. And then it hits guess. It'll search in that little field you found, and it'll find the maximum for you, which is negative 5.801. So let's say that is negative 5.81. 366. Now let's look at the next one. Move this here, so we can use it. So we want x squared. So x squared minus 1 over x. Hit graph. So it looks like that. So a couple things going on here. If I look at the range, that graph looks like it's, well, let me kind of draw an approximation of what the graph is doing right now. It looks like the graph is doing this. Like that. So my domain, there might be an issue here at 0. I'm not sure. Let's look at the table. And yes, look at 0, there's no value. Right, so 0, there's an error. So there's like an asymptote. My graph's not perfect. Let me erase a little bit. So it looks like what the graph's actually doing is this. And it makes sense. There's asymptote by 0 because of that right there. Right. Oops. And it's doing this. Right, so the domain, yeah, it makes sense. If you look at the domain of this one, it can't be 0. So my domain, you can say negative infinity to 0, union 0 to infinity. Or if you would just look at that and try to solve it, you say x not equals 0. Again, either of these are acceptable, both the right answer. My range is what we really need the graph. The domain we can always do by hand. I can do the domain of this one by hand, right? no fraction, no square root, all real numbers. Domain's easy to find. With calculator's a little bit more tough. You want to graph it. So the graph of this one gave us this one. The graph of this one, you might think, oh, it's from like 1 to infinity. But look at this guy. This guy's going from negative infinity all the way to positive without a break. My domain, my range here is negative infinity to positive infinity, or all real numbers. So that you know this one doesn't go past this. This takes account. This takes care of it. So negative and positive. That's my range. And that's the lesson.